How did the field of human-computer interaction get started? One good place to begin our story is in July of 1945, when Vannevar Bush wrote an article for the Atlantic Monthly, later reprinted in Life, called As We May Think. To date, technologies had mostly augmented people's physical abilities. Bush outlined a vision for information technologies that augmented people's intellectual abilities. Who is this guy? What's his deal? And what led to his prescient vision? Bush was vice president of Dean of Engineering at MIT in the 1930s, where, incidentally, he was Fred Terman's advisor. Terman went on to become Dean of Engineering at Stanford, and in the eyes of many, the father of Silicon Valley. In 1939, Vannevar Bush moves to Washington. He is a leading scientific policymaker. He directs a lot of the government funding, and indeed creates it. He's instrumental in setting up large-scale university research. This administrative effort eventually leads to the creation of the National Science Foundation and ARPA, institutionalizing government-funded scientific research. The goal of this article, written in the final months of World War II, is to ask what can government-funded scientists do to create a better world in peacetime, and his vision was a strongly human-centered one. Bush wrote of a future interactive desk. He calls this system Memex. The idea is that all of the world's information would be available on a knowledge worker's desktop. Key to the Memex idea was effective user interfaces for information storage and retrieval. Remember, this is 1945, and so there aren't yet practical digital computers. The first room-scale digital computers were just being built, and so the idea was to use microfiche, high-density film, to store everything. Even more impressive, Bush's Memex vision invents hypertext. He has this idea that people could author trails through this information store, save them for later use, and share them with others. But you're not always at your desk, right? You want technology to come with you, and knowledge workers need to produce content as well as consume it. And the world isn't just textual, it's also visual. So Bush imagined that in the future, you'd wear a camera right in the center of your head, like a third eye, and use it to capture stuff. And he worked out a design that made it as easy as possible to take pictures, so there are no dials or settings to fiddle with. As with the Memex desk, the details turned out differently, but the core vision was right on target. Today, for example, there are more than 1 billion camera phones that people carry with them. The programmable digital computers that soon followed, like the ENIAC shown here, were a huge technological leap forward. But as you can see from the wires, the user interface left a lot to be desired. The idea of providing a more effective interface to computers has a long and storied history, beginning with Grace Hopper's invention in the early 1950s of the first compiler. What's inspirational for me is that she conceptualized how improved tools could provide a much wider audience with access to computation. In the intervening years, good programming environments for the desktop and web enabled legions of developers to create the content that helped put a PC on every desk. It's a long path from the Grace Hopper's visionary work on the compiler to the graphical user interface. There are 3 key highlights I'd like to share with you along the way. The seeds of direct manipulation were sown at MIT's Lincoln Labs by Ivan Sutherland. The key innovation of the graphical user interface is that the user's input is performed directly on top of the system's output. This input-on-output directness makes the interface much easier to understand and much more intuitive. This input-on-output directness makes the system much easier to understand and feel more intuitive. In the case of Sutherland's sketchpad, the input was a light pen and the output was an oscilloscope. Here's a short clip of the system in action.
You can see we have several unusual pieces of input-output equipment here. We have a scope, a knob. These are unusual at the time, and push buttons, toggle switches. We have several other related devices. This made the TX2 a prime candidate for the sketchpad developments back in 1961. Now, as I draw my part, let's say, on the scope, it reinforces what I have in mind. This is, in general, part of the design process.
The next major stop on our journey is the creation of the mouse and hypertext. These are key foundations for the web. In 1945, Doug Engelbart was a Navy radar technician. Engelbart spent a monotonous year in the Philippines. In the library, he found a copy of the magazine Life. It reprinted Bush's Atlantic Monthly article. As John Markoff writes, the idea of a device that could extend the power of the human mind left Engelbart awestruck. He had a vision. It took a long time, but eventually he got some funding and set to work. And what Doug Engelbart came up with, he he showed to the world in this famous 1968 demo.
The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive to every action you had, how much value could you derive from that? And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse.
Engelbart's mouse worked with two orthogonal wheels. Each was a potentiometer, a variable resistor, like stereos commonly have for a volume knob. So you get about 300 degrees of a turn and that's it. This usable perimeter provided about 5 inches of motion in each direction. After the 1968 demo, Doug takes his show on the road. He travels the country with a 16mm Bell & Howell projector. Ivan Sutherland had recently joined the faculty at the University of Utah. Doug comes to visit and shows the demo, and in the audience is Ivan's PhD student, Alan Kay. Alan has been dreaming of a personal computer. He sees Engelbart's video and his eyes bug out. They had the same dream. After his PhD, Alan moves to the Stanford AI lab where John McCarthy's group has an early time-sharing system, maybe the first place in the world where every person had their own terminal. From there, he moves to Xerox PARC, where he fleshes out his vision of a Dynabook. Here's a picture of the prototype that Alan made in the early 1970s. This isn't a functioning computer at all. It's made out of cardboard. It's a prototype designed to communicate a vision. With this vision in hand, Alan Kay and his colleagues at Xerox PARC start building the foundation of the first real graphical user interface. It took them a decade to get it all together to get it ready to ship. Xerox released the Star computing system in 1981. The Star featured a bitmap display, a window-based graphical user interface, icons, folders, mice, Ethernet network, file servers, print servers, and email. This next clip shows the fruits of their labor.
The display screen shows your working environment. We call this the desktop. Using the Move key, you can arrange your desktop in any way you like. Making a copy of one of these blank documents is like tearing a sheet off a pad of paper. The ability of users to make their own form pads is one example of the user tailorability built into the system. The screen closely approximates the appearance of a printed page.
And I'm going to copy it into this upper document, and the new paragraph will appear here. This is a little window that lets me set the various parameters of a paragraph.
When the Star shipped, this was almost 4 decades after Vannevar Bush's vision, 3 decades after Grace Hopper's compiler, 2 decades after Doug Engelbart's first functioning system, and a decade after Alan Kay set off to work building this computer, inspired by the Dynabook ideas. This is an example of what Bill Buxton calls the long nose of innovation, that the early ideas behind a new technology paradigm are often seeded decades before the major commercial adoption. I'm sharing this history as we begin this course for a couple of reasons. First, seeing seminal work reminds me that good ideas are often clunky early on. Second, as Johnny Lee and Bill Buxton point out, if you're looking for a good future product, the seeds you need may already be out there in rough form, waiting for you to polish it into a diamond. Third, I just think these early systems are totally awesome and just really inspiring.